Thank you very much. A lot of technical presentation in this session. I'm going to change it up a bit. I'm going to talk a little bit about the commercializing of CCUS and using the example of what's going on in the UK at the moment. Just some background. I work at Toronto Metropolitan University, and I'm a principal investigator with our Centre for Urban Energy. And part of the research that we do is in the area of energy policy. And with carbon capture being a fairly topical discussion at the moment, I felt it was important during my tenure in the UK during the winter. I escaped to the UK during the winter. I look into being involved with some of the institutions there in regards to the use of this technology. I just thought I'd also start off with a slide that gives you an idea in terms of why CCUS is so important in terms of us meeting our climate challenges. And there is a tremendous amount of respect and hope that CCUS will, in the short term, be the tool and mechanism for us to try to get the climate impact of carbon emissions reduced. In many ways, it's low-hanging fruit for a lot of people in the policy space. Hopefully, it's a short-term one. In other words, in 20 or 30 years, we have clean energy that doesn't require us having to sequester carbon. So just to give you an idea of what's going on in the UK at the moment, in comparison to what's been going on in Canada, the Brits are all in on this. $20 billion has been set aside to encourage carbon capture and sequestration. They look at the North Sea and the Irish Sea as principal locations for the carbon capture, so basically offshore. 78 billion tons of potential carbon capture space. We think of Ontario probably in the area of around 500 million tons, just to give you an idea of the differences in size and perhaps why the Brits are working so hard on this. They're being very conservative, though, in terms of their forecasting initially. So, 8.5 million tons is their plan at the beginning. They do have a Department of Energy Security and net zero. So they're, from a governance perspective, they've got it organized. And that particular department has essentially gone out and told companies and industry, give us an idea of some of the industrial clusters that could take advantage of carbon capture and sequestration. There are 8 projects, clusters that have been selected by that department for further investigation. The goal is by 2030 to be between 20 and 30 million tons per year of sequestered carbon. And they've spent approximately 630 million pounds to date of that $20 billion budget. So again, not a whole lot of numbers, but a little bit of a show and tell. So this is a graphic that identifies which clusters are currently being looked at. Of those, 4 of them have been identified now by the UK government as move forward projects, 2 of which have just received a commercial agreement with the government to proceed. So they'll be proceeding this summer in developing these carbon capture clusters. That's basically the East Coast cluster on the east side, obviously, in the North Sea, and the HyNet Northwest cluster, which is just off of Liverpool, and that's in the Irish Sea. The other 2 are in Scotland, and then Viking carbon capture and sequestration, which are still being negotiated. This particular table gives you an idea of sort of this, the volumes that they're looking at doing. But what I think is most important about this table is to recognize who's involved in this, and that each of these clusters typically has an oil and gas producer associated with it, a transmission company to work on creating the infrastructure associated with moving CO2 from emitters to the sequestration location offshore, and then finally the industrial emitters themselves, who are going to essentially be the ones who will be paying for the services that are going to be provided. It's interesting to note that of these various industrial emitters, natural gas power generators are a significant group in terms of pushing these projects forward, as are the hydrogen producers, those companies that are seeking to produce hydrogen as well. The intent, I believe, is for the hydrogen production to be mixed with the natural gas as part of cleaning up the natural gas power production in order for the UK to meet its climate change goals. So I'm going to quickly just go through some graphics showing you what's involved. These are from the particular joint ventures that are developing these clusters. And what you will see in each of them, this being the HyNet, this being the East Coast cluster, they're dealing with the collaboration of industrial emitters, natural gas power generators, hydrogen production and hydrogen storage projects, all of it together to essentially find a way to reduce carbon emissions going forward. The other two that I pointed out, Scottish cluster, is still being negotiated with the government in terms of financial support, and the Viking carbon capture project, which is essentially it's in the same area as the East Coast cluster is. But these are the four that are currently being put forward. I know this is a very busy slide. What it is meant to show is that the regulations, we're just currently legislating in terms of carbon capture and sequestration. They did it starting in 2007. The first commercial project is now occurring in 2025, just to give you an idea of the time frame. And why did this happen? Well, it was something that they wanted to do, but as they started thinking about it and actually doing the planning, they realized that there were a lot of issues out there, insufficient planning, concern about economics, and so forth. They finally got things put together in the last couple of years and are moving forward, as I said earlier. Again, another graphic, but you'll see the business model that the UK government has envisioned as part of their carbon capture strategy. But you can notice on this the various business elements of it. So we've got the greenhouse gas removals, we've got the power generators, we've got bioenergy projects that need carbon capture and storage, all of whom are going to contribute to these clusters, these transport and storage networks that are being developed. There's also the ability for capturing from waste, and the industrial partners, like, steel mills, they tend to not have the economics yet to do it, but cement plants are top of the list. Again, basically where carbon capture of the CCUS is more economic for them to do and easier to do, as well as the notion of this blue hydrogen production, which I talked about before. There's a tremendous interest in producing hydrogen from natural gas. Now, I think for the policy people in the room, and I know I've met a couple yesterday who are going to be working on all of this, I think this is a really interesting slide because this comes from the UK National Audit Office, who audits this process. And what you can see is that they've determined, or pointed out at least, what are the elements that are used in determining whether or not a cluster goes forward. We've got, I think the most significant one is the emissions reduction potential and the deliverability of the project. How quickly can we get the carbon away? Basically is what dominates it. That's 55% of the decision process. Learning and innovation is the minor part, obviously. Cost considerations are 15%. And I'm going to talk just in a second about how the government is approaching this. And the economic benefits of the project is worth 20% as part of the criteria to select it. So what does this all mean? Well, basically what it says is that we need to have governments and industry define and agree on what the appropriate allocation is going to be between industry and government in developing a carbon capture project or a carbon complex. There is an importance for the cluster to be geographically located near the industrial emitters. They want efficiencies. They want efficiencies of scale, and they want efficiencies associated with moving the carbon. I was joking with the MNR folks yesterday. They created their own carbon capture directorate. They're targeting this year to be up to 206.5 full-time equivalent employees working on this in government. So again, there's a significant investment going forward. But I think what's really important is that to recognize that as a result of the way the UK government is doing it, the private sector is all in as well on this over there. So thank you very much.